Sorry I was so late. It is 6:30 and I just got home from Spokane, so here we go. Just go through these real quick. We're trying to find all the stuff for that function, right? So we'll do extreme values first, and then everything else we just kind of get all our information after we do our first derivative and do the sign chart and then do the second derivative. So derivative of this one should be easy. I looked at number 4. It doesn't look like it's going to be fun, but x minus 21. And then we got to find where the slope is 0, right? Because that's where our hills and valleys are for our extrema. So I'll set that equal to 0 and factor it. Looks like they got a 3 in common. That'll make it easier. Yep, now it's easy. Minus 7, x plus 1. So x equals 7 and x equals negative 1. Alright, that's where your slope will be 0. So then we set up this little sign chart for our slope. There's negative 1 and 7. Check the sign of the slope on this to this side of negative 1. Right, we plug in a number from over here into our derivative because we want to know the sign of the slope. So if I plug in negative 10, it's easier to do. It's more obvious if you pick a number farther away. I don't know if you've ever noticed that. Like, anyway, negative 10 squared, 100, so that's 300. Negative 10 times negative 18 would be plus 180, so it's way positive. Minus 21, who cares? So it's positive. Plug in 0, negative 21, and plug in 10. Well, it's going to be about the same as that. 300, except it'll be minus 180, minus 21, still positive. So there we go. There's our slopes. So we know it's positive slope, and then it goes down, and then it comes up. Which you probably could have guessed if you just remember what x to the third graph looked like. So we can write down our answers from this right now, or we can do a second derivative. Might as well just write down what information this gives me. So I know it's increasing. It doesn't matter what order I go. We would always used to do maximum first, but it really doesn't matter. So it's increasing from negative infinity to negative 1, and 7 to infinity, decreasing from negative 1 to 7. Looks like that's going to be a max, right? Local max. Put local or global too. I'm gonna require that on this test, and that would be negative 1. So we'll figure that y value out later. Local min at 7. I guess we'll do that now. So negative 1. That's just to the thirds, negative 1 squared, positive, so minus 9 plus 21 minus 11. So it's negative 10. 0, I think. Oh yeah, duh. Boom, look over here. So that's going to be 0. Oh, that's going to be 0 too. Except I plug in 7. That was one of... Oh, that's for the slope. Seven squared is 49 times 3, 120. Almost shouldn't even waste time with this. Yeah, this sucks. Don't do this on your test. Don't care. Just get the x values. That takes too long. So there's that. Now do second derivative for the concavity and point of inflection. That's it. So there's the first derivative. So my second derivative, see the derivative of that one would be 6x minus 18. Set that equal to 0 to find the point of inflection. So add 18 divided by 6, x equals 3. So that tells me at 3, I'm going to change from either the concavity is probably going to change. We got to check. So I check to the left, plug in 0. 0 minus 18 is negative. Plug in like 5 to 30 minus 18 is positive. So right over here it's concave down. Over here it's concave up, which on this one is easy to see on this. It's like concave down and then concave up. That won't always happen like that, but so there it is, point of inflection means that x equals 3. Don't find the y coordinate, who cares? And then it's concave up from 3 to infinity and down from negative infinity to 3. So that one wasn't bad. That's all the stuff, right? There it is. I'm not going to have you draw it either, I don't think. Yeah. So 4, this one doesn't look fun. Here we go. Hopefully you didn't forget product rule. So you get an x times that with an x. So I'd rewrite the second one to a power. And then product rule, so first one times the derivative of that. So I gotta bring the power down, subtract 1, so half is a half, and then chain rule, you gotta do times the derivative of the inside. So derivative of 4 is nothing, but that's negative 2x, and that's everything for that derivative. I'm getting low battery. It's taking a long time. Alright, so yeah, got the first one times the derivative of the second one, plus, and then second one times the derivative of x is just 1, so I got all that. Oh boy, now your guys' favorite part, which is simplifying that so that we can set it equal to 0, because we can't set that equal to 0 and solve it. So let's see, you got a net, so that's going to go down to the bottom of this term, right? These are all multiplied together, so they're all together. I got a half, so I'm just going to turn it into a fraction. That 2 will be on the bottom. I'll have the square root of 4 minus x squared. I got an x on top times negative 2x. That's negative 2x squared. I think I got everything. And then obviously negative 2 is going to go away. So we got negative x squared over the square root of 4 minus x squared. And then plus the square root of 4 minus x squared. So I better add those together, get a common denominator. That would just be 4 minus x squared. Square root of 4 minus x squared. Top of that one's good because it already had the denominator. Multiply the bottom of that by that. So you have to multiply the top by the same thing. And the square root times square root is just whatever was underneath. Combine like terms. So negative 2x squared plus 4. Would it be worth factoring that? No, I don't think so. Set it equal to 0, right? What are we doing here? We're at first derivative, so remember we're looking for extrema 3 ways. Not only when the top is equal to 0, but also where the derivative does not exist. So you do the bottom equal to 0. And on this one, we got to think about endpoints, because that doesn't have a domain of all real numbers, so we're going to have to look at that later too. So let's see, so the top equal to 0, subtract 4 divided by negative 2, so that would be what? Negative 4 divided by negative 2 is positive 2. So plus or minus the square root of 2. And then if I do the bottom equal to 0, square both sides, subtract 4. So x equals plus or minus 2, because divide by a negative, square root it. Alright, so it'll be positive 4, then plus square root it, plus or minus 2. So I have 4 critical points from that. Alright, write those down up here. Oops, points. Yeah, x. Then, let's see, domain. So go back up here, domain of that. X can be negative. That's the first thing I think of when I look at a square root. I'm like, well, can that be negative? Yes, because I'm just going to square it like positive. Oh, but thing on the side. I just do inequality. Makes it easier. I know whatever's under the square root has to be greater than or equal to 0. And then solve that inequality. So subtract 4, divide by -1, you get x squared is greater than or equal to 4. Square root both sides, you get x equals plus or minus 2. And then you have to do another little deal here. Here's -2, here's +2. You're trying to think of the sign of this to make sure this inequality is true. So if I do like -3 squared is 9, 4 minus 9 is negative, so that does not, nope, that doesn't work. I know from experience that side won't work, it'll be the middle, because it's like a parabola. So x has to be between -2 and 2, and that makes sense, because go back to this. If you go smaller than -2, like -3, you're going to square it, it's become +9, and you're going to subtract it. You're going to subtract a bigger number here, so you're going to have a negative under your square root, and it ain't going to work. Nothing over here will work. Only the numbers in the middle will. So that's our domain of that, so that tells me -2 and 2 are endpoints. This is very shaky, sorry, my hand was a little tired. Alright. So now we just gotta do our sign chart. Here's what's bigger, square root. Let's see, -2 and 2 are my endpoints, and then I got negative square root of 2 and positive square root of 2. And check the signs of my slopes. Don't need to go over here because that's an endpoint. Endpoint, and then if I do negative 1.9, man, this sucks. Plug it into my, here we go. That was my derivative. I know the bottom will be positive, so that's easy. Well, and then whenever I plug in for x, I'm going to square it, so it's going to be positive. So, if I plug in -2, I can't plug in -2, but if I do like -1.9 squared, what is that? It's a little less than 4. A little less than 4. I think it's going to be negative. A little negative. Plug in 0, 0, so it's -2 plus 4, that's going to be positive. And then plug in 1 point, that's going to be the same as that one, like 1.9, because I've squared everything, so negative and positive are the same. So there it is. Negative slope, positive slope, negative slope, and then an endpoint. So increasing -√2 to √2, decreasing -2 to -√2, and from square root 2 to 2. What else? Oh, extrema. Mins. Gotta figure out if that's local or global. -√2. Oh, well, yeah, I gotta check this one. That's a max. Could be a max. That could be a min. Alright. Just to find local or global. I don't know, that point could be down below here. For the sake of this video being too long, I'll just tell you right now, I'm not going to put that on your test tomorrow, so let's just get through this, get to the important stuff. I do want you to get to that point sometime, but I think some of you could do it, but it's going to take too long, and I'm not going to put it on your test tomorrow. So that's a min of some kind. That's a max of some kind. Check the endpoints. We would have to do that too. Well, no, I don't have to. I know that's a local max right there because it starts here and then goes down. So that's some kind of, that's another max. That one's, well, can't tell if it's local or global. And that's some kind of min, though. So then for concavity, oh boy, second derivative of that. Like I said, I'm not putting a problem this complex on your test because it'll take too long to do it. So I won't do it right now. If you did do it, good. If you successfully did it and you want to know if you got the right answer, or you think you're successful, I don't know. The answers are in the back on all of these, I think. What's next? 23. All these. So function, that's their derivative, it goes to that point, so we just do antiderivative. Which, oh, this is gonna mess me up. I'll probably do this wrong, so you guys are probably better at this than me. I think the derivative of cosine is negative sine. So going backwards from that, if I got a sine, it'll be cosine. Derivative of cosine is negative sine, so the derivative of negative cosine is positive sine. There we go. And then the derivative of sine is cosine. There we go. So I got negative, so that's my antiderivative, plus c goes through that point, so plug that in for x and that in for y, so 3 equals negative cosine pi plus sine pi plus c. Gotta do a little unit circle action here. Pi is, that's 0, right? Pi is over here. Cosine is the x direction, so the x coordinate of that is negative 1, so that's negative 1. But it was negative sine of pi. So pi is right here, that's the y value, that's 0. So that's plus 0 plus c, so that's 1 plus c equals 3, c equals 2. So your function is just whatever you got there. Oops, that should be x. That's my function. Plus c was 2. There it is. Pretty sure on the test from last year, the problem that's like this has sines and cosines in it. Just throwing that out there. Don't know if I'll use the same one or not, but might be fun. Oh, another one of these. So antiderivative. Let's see. The power of that's 1/3. So I add 1 to that. What's 1/3 plus 3/3 is 4/3. So it's going to be x to the 4/3. Alright? And then check it. And then do the derivative. So the derivative of that I would subtract 1. 4/3 minus 1. 4/3 minus 3/3 is 1/3. Yeah, so that's right. So now out here though I need something. I need to do 4/3 times this. Needs to give me 1. So that's 3/4. Just flip it, because yeah, then if you multiply it you get 1. 4/3 times that's 1 minus 1. Okay, got it. Next one's got to be x to the 3rd. 3 times that, because it'll give me 1, so that's 1/3. That one's got to be x squared. 2 times a half. And then plus 1, so that's x plus c. Plug in your point. 1 for x. Aw, be nice if they would have flipped it. 1 for x, 0 for y. Oh boy. Well, at least it's 1. So it's just 3/4 plus 1/3 plus 1/2 plus 1 plus c. So what? 3/4? Go 12ths. 9 plus 4, 6, 13, 19, plus 12, 31. So C is negative 31 twelfths because I'm going to subtract it over there. I have no idea if that's right. But if it's not, you'll figure it out why. Because you can look in the back of the book and see the answers. 3/4 x to the 4th third. I'd laugh if I got these all wrong. Oops, what's that, half? Oh, plus C. Minus 31 twelfths. There we go. It's been a long day. What's next? Gotta keep going here. 32. This graphing. Good, these are quick. Which of the 5 points in the graph showing? Oh, yeah. So we want first derivative and second derivative both negative. So go in the graph. First derivative negative means it's going down, right? It's negative slope. Second derivative negative means concave down. So I need negative slope, concave down. There's P has negative slope, but that's concave up. That's positive, positive slope, positive. So it's got to be T. Negative slope, and it's concave down. So 32A is T. B, you need Y prime negative and Y double prime positive. So negative slope, but with a positive concavity, concave up. So what? Negative slope, concave up. That's P. Slope's negative and it's concave up. Those are all, that's positive slope, positive concavity. R would be like negative concavity. Who cares? Next one. 33. Estimate the intervals on which f of x is increasing. Oh. So they're giving you the derivative. This one's kind of tricky because I don't like the way they worded that. That's the derivative graph, and so you're trying to figure out where the original is increasing. Well, this is the derivative graph. Yeah, derivative graph. So these are my slopes. So positive slope, it's increasing. So it's the interval for where the original is increasing is just -3 to -2, and from 1 to 2. Right, because that's just where these are positive or above 0. Decreasing below 0, so -2 to 0 with an open parenthesis. These would be enclosed. Well, no, they wouldn't. They're all open. Stupid. Never mind. And from 0 to 1. And then local extreme values. So endpoints. And then you got to say if it's a max or a min. So at that endpoint, to the right of that endpoint, the slope, remember this is slopes, the slope is positive to the right of that endpoint. So you have an endpoint and then a positive slope, that's a min. So negative x equals -3 would be a minimum. Let's see, where the slope does not exist right there, that could be an extreme value. Oh, where the slope equals 0. Oops, forgot about that one. Go backwards here. Slope changes from positive to negative. So slope changes from positive to negative. It's a max. So -2 is a max. Then down here, slope. Let's see. Slope's negative, and then it's still negative. Huh? That's weird. But it changes like from -2 to -1 abruptly. Would that be a corner? Some kind of corner, yeah. Slope goes from -2 to -1. Huh. Anyway, it doesn't matter. Slope doesn't change sign, so it's not going to be a max or a min. It's just going to be something like that. Who cares? Think about that for a second. And now slope changes from negative to positive. So negative to positive, min. And then over here we have an endpoint with a positive slope to the right of it. So an endpoint with a positive slope to the right would be that way. Positive slope. Or to the right. Why am I saying to the right? It's to the left. Anyway, so that's a max. So that endpoint's a max. That's 33. What's next? 35. Oh, okay. Going back to that same graph, we're going to sketch a possible graph of the original, given that it is continuous with domain. Okay, so here we go. I'm going to draw the original. let's see, there's our domain. Oh, and f of negative 3 is 0. So we're going to start here. F of negative 3 is 0. And we're going to draw a possible graph of the original. Make sure I had my thing right here. So it looks like I start. Oh, this will give me. That's nice that that's a straight line because I'll know what the slope is. Well, never mind. That was stupid. Let's see. Positive slope, right? From negative 3 to negative 2. We're going to have a positive slope, and then it's going to change to a negative slope at negative 2. So that's going to be a hill. So we'll do some kind of hill. Snow. I'm not going to draw it quite yet. It makes it easier. Well, and I'm using pen, so I don't want to mess up. So we got a negative slope getting more negative till here. Till 0. So it's just going to go like that. And then we're going to all of a sudden just switch to that. That's weird. And get more positive. Trying to think if there's something I'm forgetting here. I don't think so. Some kind of corner. And then the slope is still negative, but it's getting close to 0, and then it's going to change to positive. Oh, I gotta do my concavity a little better. This is all concave down because, right, the second derivative, so the slope of this line is negative. So the second derivative, I'm thinking of the second derivative. The second derivative would be negative for this whole time because the slope of that is negative. So that's all concave down over here. So good, I've got this thing all concave down. And then over here, the slopes of that is all positive, so I know I'll be concave up over here. I'll have a, see, change from negative to positive, have negative 1, or positive 1. And then get more and more positive to my end point. So, I don't know, something like that. Who cares? Just make sure you're concave up right there, concave down right there. Got some kind of max and some kind of min and endpoints. And that probably give you one of those just because it's fun and I like to see your pictures. Let's see what else. 33, 34, 35 did that. Oh man, this was a lot. You a mean teacher. None of you needed the video till now anyway, probably, because if you actually tried them all, it doesn't take a long time. Area of a triangle. So an isosceles triangle has a vertex at the origin. Okay, so we got a picture here. Vertex, isosceles triangle, so two sides the same. Vertex at the origin. So right there is going to be a corner of the triangle. And with its base parallel to the x-axis, and its vertices above the axis. So the base is going to be up here somewhere. And it's going to go down like that. Oh, and the vertices are on the curve 27 minus x squared, so it's an upside down parabola. Alright, so that's just negative x squared plus 27. So it's just an upside down parabola with its vertex at positive 27. And then it goes down a parabola like that. So I got a triangle in there like that. And it's an isosceles triangle, so I know those sides are the same. And those vertices hit that parabola. Okay, now what? I haven't even read the rest. Find the largest area. Okay, so area of a triangle. Oh, this could get tricky. Let's see. Area of a triangle is 1/2 base times height. Oops, BH. Has to be neat. I'll mess up later. So, gotta find the base and the height of that triangle. Oh boy. So the base, anyway, that looks easy. I'll just call that x, right? Well, 2x, because it's going to come out, whatever, whoever knows how far, and that'll just be x. So the base of that will be 2x. So I know over here. The base is 2x. The height is going to be the distance from here to here. So it's like the y-intercept. Or yeah. How would that work? But you have to depend on x. So if you come over, is it just this equation? I believe so. Whatever you get for x, plug it in, you'll get the y value. And that will just be the height of the triangle right there. It's just the y value. Yeah. That usually happens on these. Right? Because if you just plug it, whatever you pick for x, so like say you pick, I don't know, let's just pick a number. So say x was 1. So I want my base of my triangle, I want this to be 1, so the base be 2, who cares? If I plug it in 1 for x, what would I get for y? Negative 1 squared is negative 1 plus 26, so I'd be way up here. So the height of my triangle would just be 26 because that's the distance from where those would hit to there. So. Right, and it's a parabola, so we know this is going to be the same. We know it's going to be level. It's symmetric. So there's my base and my height. So now, what are we trying to do here? Maximize largest area. So we're maximizing the area. So my function for area will be 1/2. The base is 2x. The height is negative x squared plus 27. And I'll use my calculator to maximize that. Let's see. Pushes buttons in my backpack. Should probably put the cover on. Don't tell Mrs. Crow I just said that. There's that. Let's see. Before I even hit graph, I want to think about my picture. Well, I got one right here. So my window, I'll go from, I don't want this 0 to 200 crap. I don't know, that's 27, so that can't be more than like 27 or 30. I don't know, 27, who cares? Y min 0, Y max I know is 27, so I'll just put 28. Oops, that doesn't look right. What did I do wrong? Oh, I need my negatives. X min negative. And that looked way too skinny, so I'm just going to go like negative 10. 10. And y min would be 0 to 20. Yeah, let's try that. That was horrible. What the heck happened? Oh, duh. I'm graphing the area of the triangle. I'm not graphing the parabola. That was stupid. Alright. Well, what do I need here? I need to go taller. So y min, I don't need negative area though. Oh, and I don't need negative x's either. Duh. Okay. See, this can happen to you during your test too. You can do the same thing. Okay, maximum area then, right there. Just find that point. Calc max. I don't know. Let's go. 12. Is that far enough? Oops. Nope. Hit go to, and that means you punch the number in too high if that happens. I just picked 12 because I wanted to pick a point over here, but I went too far. It's off the graph, so I gotta make a smaller one. So I don't remember. Let's go 8. I'm just, oops, 82. No. Go to, delete, guess. I don't even know where the thing is. Let's see what happens. Yep, it worked. Next, x equals 3, y equals 54. So, what was the question? Just the largest area. I didn't ask for the dimensions of the triangle, so there's my largest area right there. Area equals 54 units, whatever it was, who cares? Squared. Hopefully that's right. What next? 47. Oh, I think these 47 and 48 are the large tank problems. So they should be pretty similar. Find the dimensions of the largest open top storage bin with a square base and vertical sides. It's like a cube. I just did that really weird. Cube drawing skills have gone downhill this year. Let's see. Largest square from 100 could be made from 108 square feet of sheet steel. Neglect the thickness of the steel and assume there is no waste. Oh, okay. So the piece of steel that you're going to use to build that, they give you 108 feet squared. So that's the surface area of the piece that you're going to fold up into that box. So I know my surface area of the equals that. So we want to find the dimensions of the largest open top. So what, biggest volume, I'm guessing? So we're going to try to maximize volume. I'm going to max that. So I got to do the volume of my box. So one side will be X. Does it say square or anything? Or just open tops? Gotta read these like 4 times. With a square base, yes. So that's nice. So I know those are square or same. So if that side's X, that side's also X. And then it's probably just need a height now. Yep. Need to figure out my height. So when I know I'm doing volume, I'm doing length times width times height, but so I'd have x times h. I need one variable though, so we got to figure out what h is. So this is where you have to write another equation. So I'll probably use surface area. If I know it's 108 feet, if I just put my formula for surface area over here, I can solve. So surface area of a cube, that's just area of all the panels, right? So we got the front, the side, this side, the back, and the bottom. There's no top. So front, actually all the sides, is just x times h, right? X times h over here, x times h. So I got x times h 1, 2, 3, 4 times. So let's see, 4 xh. That's all the sides, and then the bottom would be x times x. So plus x squared. That's my surface area. If I do that, I'll get 108 square feet. So now I can solve for h so that I can plug it in over here when I do volume. Right, because my volume right now, I said base times width times height, so it'll be x squared